Hi everyone, I am Dr. Prabha, consultant ophthalmologist. Welcome to Ophthalmology Made Easy, your go-to channel for clear, structured, and exam-focused ophthalmology teaching. Today, we are starting a brand new series, and it is one of the most fundamental topics in ophthalmology, corneal anatomy. This is a three-part series. In part 1 today, I will cover the introduction to the cornea, its measurements, and the epithelium in detail. In part 2, we will go through Bowman's layer, the stroma, and Dua's layer. And in part 3, we will finish with Descemet's membrane, the endothelium, and the nerve and blood supply. This is high-yield content for DNB, MS, DOMS, optometry, FRCS, and FICO examinations. So grab your notes and let us get started. The cornea is part of the outer coat of the eye. The outer coat, also called the fibrous coat, consists of two parts: the cornea anteriorly and the sclera posteriorly. Together they serve as a protective structure for the delicate contents of the eye. Now, what makes the cornea special compared to the sclera? Two very important properties. The cornea is transparent and the cornea is avascular. These two properties are absolutely fundamental, and understanding why the cornea maintains these properties is a recurring theme in corneal pathology. The cornea contributes 2/3 of the total refractive power of the eye. This is an extremely important and frequently asked exam point. The total refractive power of the cornea is plus 43 dioptries. This comes from the anterior surface contributing plus 48 dioptries, and the posterior surface contributing minus 5 dioptries, giving a net total of plus 43 dioptries. The refractive index of the cornea is 1.376. Please remember this number. The cornea is aspheric in shape, meaning it is not a perfect sphere. It is flatter in the periphery than at the center. This is clinically important in contact lens fitting and refractive surgery. The anterior radius of curvature is 7.8 mm, and the posterior radius of curvature is 6.5 mm. Now let us go through the measurements. These are frequently tested in theory and clinical exams. Horizontal diameter, 11 to 12 mm, vertical diameter, 9 to 11 mm. Note, the horizontal diameter is larger than the vertical. This is why the cornea appears oval when you look at it directly. In males, the corneal diameter ranges from 11.04 to 12.15 millimeters. In females, it ranges from 10.7 to 12.58 limit. So there is slight sexual dimorphism. Males tend to have slightly larger corneas on average. Corneal thickness, at the center, 0.52 millimeters, approximately half a millimeter. At the periphery, it is slightly thicker, around 0.67 meter. This difference in central and peripheral thickness is important in glaucoma assessment because corneal thickness directly affects intraocular pressure readings. A thinner cornea gives falsely low IOP readings, and a thicker cornea gives falsely high readings. This is why central corneal thickness measurement, called pachymetry, is essential in glaucoma evaluation. Now let us move to the histology. This is where most of the exam questions come from. So pay close attention. The cornea has 6 layers from anterior to posterior. 1. Epithelium. 2. Bowman's layer. 3. Stroma. 4. Dua's layer. 5. Descemet's membrane. 6. Endothelium. A very popular exam question. How many layers does the cornea have? The answer depends on the year of your exam. Before 2013, the answer was 5 layers. After 2013, following the discovery of Dua's layer, the answer is 6 layers. Always mention this in your answer. Today, we will cover the first layer in detail, the epithelium. The corneal epithelium consists of stratified squamous, non-keratinized epithelium, which is continuous with the conjunctival epithelium at the limbus. The epithelium has 3 layers. 1. Deep columnar cells, the basal layer. 2. Middle wing cells, also called umbrella cells. 3. Superficial flat cells, the deep basal columnar layer. These are columnar, palisade-like cells arranged in a single layer. Cell width is approximately 12 microns. This layer contains germinal cells, which produce daughter cells by mitosis. These daughter cells migrate anteriorly, first becoming wing cells and eventually differentiating into the superficial flat cells. So the basal layer is the regenerative engine of the entire epithelium. Everything above it originates here. Metabolically, basal cells have very few organelles like mitochondria and endoplasmic reticulum. This is why they depend on the pentose phosphate pathway, also called the hexose monophosphate shunt, for their metabolism. This is an important exam fact. Laterally, basal cells are joined to each other and anteriorly to wing cells by zonular occludens, tight junctions. Now, the adhesion complex of the basal epithelium is clinically very important. Basally, the basal cells have a basal lamina, which is PAS positive. It blends indistinctly with Bowman's layer below. The firm adhesion between basal cells and Bowman's layer is achieved by hemidesmosomes and type 7 collagen. Clinical pearl. This adhesion complex is critical. When it is defective, as seen in conditions like epidermolysis bullosa, bullae or blisters form between the epithelium and Bowman's layer. Reduplication of the basal lamina is seen in aging and in diabetes mellitus, leading to recurrent corneal erosions, a very important clinical association to remember. The middle layer, wing cells. This layer consists of 2 to 3 layers of polyhedral shaped cells, called wing cells or umbrella cells because of their shape. They represent the intermediate stage of epithelial differentiation, the most superficial layer, representing the highest level of differentiation. These are chronologically the oldest epithelial cells. They originated from the basal layer and have migrated all the way to the surface. Key features of the superficial cells. Anteriorly, they have microvilli, which increase the surface area. These microvilli have a glycocalyx coating, which helps in the attachment of the tear film. This is why disruption of the superficial epithelium leads to poor tear film stability and dry eye symptoms. Laterally, desmosomes and zonular occludens are present, which have a barrier function, preventing organisms and fluid from penetrating inward. Clinically, fluorescein dye is used to assess whether this epithelial barrier is intact. When the barrier is broken, fluorescein stains the exposed areas, seen as green dots or patches under cobalt blue light on the slit lamp. Functions of the epithelium. Summary. 1. It has regular thickness with a smooth wet surface, serving as the major refractive surface of the eye. 2. It acts as a barrier to microorganisms, preventing infection. 3. It prevents fluid loss from the eye surface, maintaining corneal hydration. Let me quickly highlight the most important exam points from today. Point 1. Cornea contributes 2/3 of refractive power, total plus 43 diopters. Point 3. Refractive index is 1.376. Point 4. Horizontal diameter greater than vertical diameter, 11 to 12 mm horizontal, 9 to 11 mm vertical. Point 5. Central thickness is 0.52 mm. Point 6. 6 layers since 2013. Point 7. Basal cells use pentose phosphate pathway. Point 9. Adhesion via hemidesmosomes and type 7 collagen. Point 11. Superficial microvilli with glycocalyx are essential for tear stability. Before I close, here are 3 questions for you. Question 1. What is the total refractive power of the cornea and how is it calculated? Question 2. Which pathway does the corneal epithelium use for metabolism? Question 3. Name the components of the epithelial adhesion complex. Thank you so much for watching part 1. I truly hope this was clear and helpful. If you found this useful, please give this video a like. Share this with your batchmates. Press the bell icon so you're notified for part 2. Bowman's layer, the stroma, and Dua's layer are coming up next. Drop any topic requests in the comments. See you in part 2 very soon.